All right, Lyle has asked me to review the left and right joins again, so let's make this a challenge. Somebody give me an example of what might be a left or a right join, where I might want to use it. Give me an example problem. Guess that's the first problem. All right, let's take a look at the tables here. Everybody's quiet, nobody wants to volunteer. When we use left and right joins, it's because I want all the records from the parent table, even if there's no corresponding child table. My example that I've done twice already, and I'm glad to do it again, is give me a list of all the trips that employees have taken, but include all employees, even if they've never gone on a trip. So let's start with that again, and then we can dream up another one. So what do I want to know about these employees and their trips? Let's get the employee's is it last name? I already forgotten. It's amazing what 2 days does to me. Last name, first name, trip date, expenses, destination. None of this makes any difference. This isn't the problem. All right, the field list is not the problem. Problem comes in when we start linking these things together, right? Because these are left-right joins. They're outer joins. They are used to say, I want all the employees in this list. If I do a regular join from employees, TBL employees, joined to TBL trips using trip ID. By the way, I have updated my notes and got rid of all the aliases that weren't necessary, and there were a couple of usings in there that didn't work, that wouldn't have worked. That's what I get for putting examples in my notes that I can't really test. But I think I've got the notes updated. I'm going to look at Jessica. She's doing it all the time now. If you see anything else in there that I missed, please let me know. And let's list these by last name, first name, and trip date descending. Anything there that's confusing? I'm just joining those two tables together, right? It's a pretty straightforward join. And then sorting the results. Maybe. What's the problem? Employees is selected, unknown column, trip ID. Oh. And there's my trip. So there's all of Tammy's trips, and Tammy last went to Chicago, then Miami, and that's all well and good. But if we scroll down here to the G's, so remember we did add me back in again. Where am I? I'm not there. Because when you do a join of two tables, you only get the records where there is a where they correspond, where they link. There is no trip for me because I have not gone on one in this database. So I don't show up. It's just like customers and orders. Give me a list of customers and their total order amount. Well, if I've got 15 customers in my database who've never ordered anything, they don't show up on that query because they never ordered anything. There's no corresponding order table entry for those customers. So if I do want to see all those customers, if I do want to see all of the employees, regardless of whether they've gone on a trip, so that I can see who hasn't gone on a trip, then I need to do an outer join. Two kinds of outer joins. There is no keyword outer, remember that. It's just what they're called. There's no statistics keyword, but the sums, the averages, the mins, the maxes are called statistical queries. There's no keyword outer. There are just left and right joins. I believe your question is, how do I know whether to use left or right? Here's what I recommend. Put these back together on the same line. There's my join. Right now, that's an inner join, which means only show me corresponding records. Right? The word inner is optional. Could put it in there. Right, so here's my inner join, and I have one table, two tables that I'm joining together, right? Which one's the parent? You agree? Why not? What does parent mean? Let's back up and make sure we're all on the same page. What's parent mean? It's which side of the one-to-many relationship? One side of the one-to-many relationship. Can one trip be taken by many employees? Not in one record it can't. If 3 employees go on the same trip, we got 3 trip records. So the employee table here is the parent, because one employee can take many trips, but one trip is taken by only one employee, the way we define it here. What your left-right has to designate is which side of this inner join is the parent on. Which side? I mean, literally, which side is the parent table on? The left side. So that's your question. Right. Generally, you're looking at the parent table. It is possible to say, give me a list of all the trips that don't have a corresponding employee. Why would I have that? Why would I have a trip that isn't linked to an employee? Maybe I deleted an employee. Usually not a good idea. Old database, bad data, bad program, entered a trip and the employee didn't get linked to it. So we might be using it for debugging, but those are rare. More likely that you want to link the parent. So the parent's on the left side here, so we call this a left join. That's all it means. It's where, and that's how I would think about it, at least right now, is where's the parent? If you put the inner join and the 2 tables on the same line, which side has the parent? Now there's a record for me. If for some goofy reason I had said from TBL trips, inner join TBL employees, that still works, right? Joins them together. I just flip the tables around. When you're joining them, it doesn't always, especially when there's 2, it doesn't make a difference. When there's 3 or 4, sometimes the order that you join things makes a difference. But here it doesn't make any difference. Now if I want a list of all of the employees included, here's my inner join. The parent table is on the right. So I do a right join instead. Should get the same results. Notice down here we have 301 rows. 301 rows, still sorted the same way, and I'm sure if I went down far enough I could see golf. But there's another thing we can do here. If you want to just see the people who haven't gone on a trip, I mean, think about that. How do I get a list of people who've never gone on a trip? Can I look in the trips table to find out who didn't go? No, I only have a list of people who did. And so to reverse this logic, there's a couple ways we can do it. But one way to do it is to do an outer join, so give me a list of all employees, but only include the employees where the trip date is null. Got a couple of zeros there that I didn't expect, so I can put an and in here, the expenses equals null. That might be even better. I don't know why these zeros are here, honestly. Some bad data in there. But I can ask, is it null? If we wanted to see a list of all the trips that don't have a corresponding employee, I can do an outer join, left or right, depending on where your trips table is. and ask for a list of trips where the last name is null. And I have a bunch of trips with no last name associated with there's no name. So you can flip them around. It's one of the things I have you do in the beginning access class, or maybe it's the intermediate access class, is give me a list of orphans, trips without parents, trips without employees. Shouldn't be any, right? Let's find out. Easy to find out. Just flip it around and say, give me a list of all the trips, even if there's no employee involved, where the last name is null. Last name null would mean I have a trip with no employee associated with it. And as expected, there aren't any. But that's a good sign, right? If you're the database administrator and trying to be efficient and make sure your data is accurate, do a little bit of analysis here. I hope there's no orphan records here. This is one way you can find out if there's an orphan involved. Check for children without parents. The other way around, we had parents without children, people who haven't gone on trips. That's legal. Happens. Students without GPAs. Haven't finished any classes yet. A lot of those students. Does that help, or you want another one? Anybody else? Other topics you're still confused about that we've covered? I'm getting the impression that Lyle tried to do a couple of queries since our last class. And I encourage you. That's why I try to give you a little bit of lab time. This one not so much, but in between classes, try doing some of those queries. And all of a sudden questions pop up like left-rights. In the systems class, they're learning about building tables and inserting records. You go, that's exciting. But the networkers are learning how to do that. We did a review after spring break, and a couple of people said, I just turned in an assignment. Can you ignore that one? Because they heard something in the review after they've done the assignment, or tried to do at least part of it. Then they went, oh, that's why I missed that. So try some of these things. And if you have questions, bring them to class. All right. Last time we joined a table to itself for the book examples. The only reason you're doing that is to find records in one table that are related somehow, because they have the same category, because they have the same price. So we're using one table, joining it to itself. Real world, a better example, I think, is linking a supervisor to an employee. We did some examples last time. I believe we started talking about subqueries. The most advantageous thing for subqueries, this is the only way to do this, is to compare values to statistics. Give me the person with the highest credit limit, or this one has to be the person because of the equal sign. Today we're going to learn about in. Because there's an equal sign there, this says, give me a list of the people who have the one maximum credit limit. There's only one max, right? Can only be one max. Could be lots of people with that credit limit. This is using subqueries is the only way to make this happen. There is no way using a join that you can say calculate a statistic and then join that with customer first name and give me the ones who have this criteria. It doesn't work. So subqueries have their place. So another example, give me the people who scored less than the average on the test. We did something like that with expenses or salaries, if I remember right last time. Give me the donor who made the largest donation. Give me the donors who are bigger than the average donation. Some examples. Another thing we can use subqueries for, and I think we did this. Yep, we did this because I remember talking about the gateway computer here. We can also use subqueries to link tables, sort of. Are we linking them here? In a way. What we're saying is give me the location of the PC whose ID number is equal to the one value returned from here. This subquery returns a single value. It has to return one single value when you do subqueries. Big important part about subqueries, there's never a list of fields here. There's one field. There's never a star there. There's one field. Or one value. Remember up above we had min and max. That's one value. So in this case, I'm making an assumption that there's only one gateway computer in my entire company. What's its ID number? That ID number then gets kind of plugged in here. It's kind of like calling a function in C#. This gets replaced with the ID number, and it says where the computer ID number equals 17. Where is it? That's what this query would tell me. When you do this, it's kind of a sideways way of joining things. I don't do it very often, but occasionally queries get so complex with all these different tables that I have to link together and criteria that the joins get complicated. And occasionally a subquery can help you with that. Here's the same query. Give me the location of the PC that has this ID number. Or link them together, but give me only the records where the manufacturer name is Gateway. The difference between these two is this one absolutely positively returns one value. This one has the potential to return multiple gateway computers. This just says give me a list of all the locations for all the PCs that are gateways. Because we're using a subquery up here, I can only return a single value. And so this one only works if there's only one gateway computer. If there are multiple gateway computers, this query fails. Gives you, I think, an answer of nothing. Doesn't crash, fails. Gives you nothing.
Doesn't it give you a message? Yeah.
I don't think so. It just goes out there and it gets confused. It might give you a crash when we're done, so let's give that a shot. Make sure I'm not lying to you again. So I want to say, give me a list of employees who work at plant number, who work in Coloma. But I don't know the ID number of the Coloma plant, so I'm going to use a subquery for that. Actually, this is not a bad query. This works pretty well. So let's do this one as an example because this is going to work. Where what? Where the select the plant ID from the plants table. Where the city, is that what it is? Plant name is Coloma. How many plants have that name? One. So this query is going to return one single value. This should work just fine. It'll give me a list of all the employees who work in that plant. 13 out of 50. So that works, but that's not what I was trying to demonstrate. What I want to do, it's what happens when Joni asks me questions on the fly. I have to come up with a couple of examples to get it right. Give me the trip date and the expenses from TBL trips for, let's try it this way, where the employee ID equals the employee ID for Amiga. I don't know the employee ID for Amiga. I could do a join. But instead, I'm going to say select the employee ID from TBL employees. Where last name equals Amiga. You might remember there's two of them, right?
Probably one.
Pardon me?
Amiga is probably one.
Yeah, there's a couple. So this query is going to return two values, two rows. What happens? I get an error. Subquery returns more than one row. So when I said it just gives you nothing, I lied. It does give you an error. The subquery returns more than one row. But what's wrong with this? This is what's wrong. If you use an equal sign for your subquery, the subquery has to return one value. If you expect your subquery to return more than one value, like I do here, I have 2 Amigas in the database, and I want a list of their trips. And use the in clause instead. You can still only have one field here, but that query can now return more than one value in that field. By using in, it says, give me a list of all the employees whose last name is Amiga. If the employee is in that list, then show me their trips and their expenses. Why wouldn't you do that with a join? Could. Except I'm not asking for anything about their name. I'm not asking their phone numbers. I'm not asking anything about the employee. I just want a list of the trips and the expenses. Not the greatest example, but I don't need anything from the employee table. So instead of doing a join, I can do a subquery, but wouldn't a join be easier? Not necessarily. What would the join look like? And we'll see which one's easier. In this case, it's probably not going to be much of anything. Select the trip date and the expenses from TBL trips joined to TBL employees using the employee ID where the last name equals Amiga. It's 4 lines long, but really not much longer, not much different, is it? One up above is a little longer. How many records did I get? I got 12. Same answer. Occasionally, the subquery makes life a little bit easier. When you're doing your homework assignment, if I designate use a subquery, then use a subquery just to demonstrate that you understand subqueries, not that it's necessarily the appropriate technique for doing this. If I don't designate which one to use, then you should be using a join. Difference between equals and in. If you're using subqueries, this subquery can only return one single value when you're using an equal sign. The subquery only returns a single value. You're often searching for the primary key in that subquery. If you use the word in instead of equals, then the subquery can return multiple values, but still from a single field. If you get this lovely error message, error, the subquery returns more than one row, you go, oops, change the equal sign to an in. That's all you need to do. Questions? Here's in. We saw it before. Remember, we gave it a list, kind of like an array. Gave it a list. If the state is in here, one of these 3, then give it to me. This kind of does the same thing, except the subquery translates into this. This query that's on the screen says, give me the names of the customers whose representative is responsible for their state. Where representative 1211111 is responsible for their state. Well, this sales rep is probably responsible for 3, 4, 5, 10 states. So the state value will have probably multiple values. So give me a list of all the customers who are in this guy's region, if you will. Again, that query could be done with a join. We just join the two tables, customers and assignment. And oh, see, that gets a little more complicated here. Customers and assignments. Customers don't have assignments. Customers have reps. So I'd have to join 3 tables here, I think, to get the information that I need. No, I take that back. Customers don't have, no, I take it back again. Customers don't have assignments. Reps do. So in order to duplicate this query, I'd have to join 3 tables at least. I don't know the structure here. Again, it's one I made up. I'd have to join, I'm guessing, at least 3 tables. Customer to rep to region or state. So that I can say, give me the states of all, or give me the list of customers who are in sales rep number 111, that's a rep, the list of states that they are responsible for. That's another table. So this one, I think it's easier to do a subquery. But like programming, when you're a new SQL programmer, if you come up with a solution that works, go with it. If I know about a simpler way, I'll share it with you. But doing the one up above using 4 joins instead of 1 subquery would work. Subqueries can be nested. Here I'm saying, give me the list of customers. And here's the 3 table version of that. Give me the list of customers who live in the state that has been assigned to sales rep named Gall. Notice here I'm using Gall instead of the ID number. That's what makes it a little bit different. We can use subqueries inside of subqueries, and once again, you build from the inside out. You make a list of, or first you get the ID number from the staff table. Make sure that works. Then you get a list of states that are assigned to that sales rep, make sure that works, and then get a list of customers who are in the states that are assigned to that sales rep. So here's an example that we can play with. List the foreman of the employees who have traveled to Chicago. So now we're talking plants linked to employees, linked to trips. Right? We can do that using a join, but I'm first going to do it with subqueries just to demonstrate the nested subqueries. I want to know the list of foremen for the employees who have gone to Chicago. So I think the first thing I need is a list of employees who have gone to Chicago. So I'm going to say select the employee ID from TBL trips, where the destination is Chicago. And just to be extra sure, temporarily, I'm going to say give me the destination here as well. Okay, Chicago, 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 Chicago. Got some duplicates, right? Yep, there's somebody who's been to Chicago. There's another one's been to Chicago twice. Doesn't matter. Gives me a list of IDs. That's ultimately what I want, of people who've been to Chicago. Now I want the employee names, or the IDs. So I'm going to have to switch to a subquery. Select the employee IDs from TBL employees, where the employee ID is equal to, no, in, because my trips table's got lots of results, right? So I have to use in, where the employee ID is in that subquery. Now what's interesting about this part, watch what happens. Remember there's duplicates, right? Probably should sort them. Oops. Crash. Operand should only contain one column. I was testing to make sure that my destinations were Chicago. I broke my rule here. There's 2 fields here. When you do subqueries, 1 field. Down here it says should contain 1 column, 1 field. I've got 2 columns in my subquery. These look like they're in order already. They're sorted. And there are no duplicates. Because of the way this query is built, this says give me the employee ID of anybody who's in the list. Are they in the list? It doesn't ask how many times. So we're walking through every employee. Are they in the list? 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 Is all we care about. They will never be duplicated because we're using the subqueries here. Because of this in clause, we're walking through the employees. They can't be duplicated. Because we're looking at each employee and saying, are they in the trip list? Are they in the trip list? Are they in the trip list? And what we get is a list of employees. If I had just done select star from employees, how many times would each employee show up? Once. Here I'm saying, don't give me everything, just give me the employee ID of the employees. That will not duplicate because I'm getting the ID from employees. So this gives me the list of the employees who went to Chicago. There's the list, 20 people. But I don't want the list of the employees. I want their supervisor's name. And that's foreman. So now I can use another subquery. Select the foreman from TBL plants where the plant ID is in this subquery. Now that's a bit of a problem because I don't have the plant ID in here. Doesn't mean I can't change it. Then I need a double set of parentheses because every subquery needs to be surrounded with parentheses. Now we had 20 employees. How many plants are there? 4. So how many records do I expect here? 20 foremen. It can't be. There's only 4 plants. How can I have 20 foremen? Should get duplicates. No, because I said select the foreman from plants. There can only be a maximum of 4. Who work in a plant that employees work in who went on trips to Chicago. I expect 4. Just so happens that everybody, or at least one person from every plant has been to Chicago. I might be able to pick a different city and make that smaller. Is this easier to read than this? I believe it says the same thing. Join the 3 tables together. So I get plant information, get employee information, trip information, all spread out. But now filter, only give me the ones from Chicago. This says give me the list of foremen for everybody who's been on a trip to Chicago. When I run this one, what's going to happen? Now that I've done a join, I get all the duplicates. because it's a join. Remember, it joins tables, big old long rows. If I want just a list, distinct. I think I mentioned the last recording because somebody asked me, how do I know whether I need distinct or not? If you're doing subqueries, a lot of times you don't need distinct. But if you're using joins, very likely you'll need it. My advice is run the query. If you get too many records because you got duplicates, add the word distinct. You'll stop getting duplicates. But I wouldn't put the distinct in unless you've got duplicates to deal with. Because the distinct adds one more level of analysis that the SQL compiler has to do to look at your data and say, filter out any duplicates. Doesn't make any sense to filter out any duplicates if none of them are ever going to show up. The point there is I can nest subqueries as deep as I need them to go to link tables together, which is basically what we're doing here. But it can add some complexity, can make it complicated. Can we mix and match? Absolutely. Sometimes it's easier to write a subquery instead of doing a complicated join. So you can do a couple of joins where the condition is based on a subquery. Yep. Mix and match any way you want to. You've got some tools here that you can use. Next topic. Not hearing any questions. Hope you jump in there if you got them. Set operations. Set operations allow us to run two or more queries and combine their results. Let me see if I can wing something here real quick. Oh, I'm in the Mac, which makes it a little more challenging for me. Let's do Microsoft Word. That should work if it's still installed. Once upon a time, back in elementary school, junior high, talked a little bit of geometry and you talked a little bit of set theory. It wasn't called set theory, but it's what it was. Remember from our early discussions of relational database management or databases that they're based on set theory. Set theory, and now we're getting into the set operations. Right, so we're going to talk about it a little bit more. Set theory just talks about how do two groups relate to each other. So if I have two of these circles, one circle could be, let's imagine that circle as the answer to a query. I run a query and this circle contains all of my records. What set commands allow us to do is take two sets of queries and combine the answers. So we're going to take two queries and imagine I put the answers on one page and the answer on another page, and you use Microsoft Word and just attach them together. That's what set operations allow us to do. There are three kinds of set operations that are available in SQL. The first is called a union of the two. The union of the two, oh, I miss my Windows version where I know what the heck's going on. Would like to fill them, but I can't. The union of the two are the insides of both circles combined. Which is what I just described. We take the answer to one list, take the answer to the other list, and we just concatenate them together. But even better than that, if there's any overlap, we remove the duplicates. A union will automatically remove duplicates. So think of me, if I had my paint bucket that I have in the regular Microsoft Word, imagine me filling this circle and this circle, and we have these two filled circles right next to each other. So that's a union. If the two circles don't overlap, we can still have a union, and now we just have two very distinct sets that are connected. But when you do a union, if there's any overlap, the duplicates are automatically removed. Another operation we can do with sets is an intersection. An intersection is where the two overlap. So all we would get is this little weird shaped thing, this little disk in between here. If you do an intersection, is where do those two overlap? What part do we get? And the final thing we can do with SetQuery is a minus. And the minus says, give me this one minus anything that overlaps with that one. So I would kind of get this eyeball shape over here. Let me draw those on the board. Almost looks like a U. Think of this as set A, and this is set B. This is query A, this is query B. If we say A union B, we're talking about all of this stuff. With the duplicates removed. If we're talking about the intersection, we're only talking about this part. Where do they overlap? What do they have in common? And finally, down here at the bottom, a minus. If we said A minus B, we're talking about A minus everything that it shares with B. So now we're talking about this stuff. Make sense? So how do we do that in SQL, and why do we do it in SQL? Best example I can give you is a database that I designed for Midstate Tech that does analysis of surveys. So after you've been graduated for 3, 4, 5 years, we send you a survey and say how things are going. You got a job in your field, how much you're making, does your employer like you, do you like your employer, etc. By the way, when you get that survey, do us a favor, send it back. It's very helpful for us. Lets us put things on our advertisements like 98% of students have jobs within 6 months after graduation. 98% of students have jobs in their field. Those kind of statistics that we like to brag about, we can only brag about if you send us the surveys back. So that was a little commercial there. But when we send those surveys out, we send them to two different groups of people. We send them to students who get degrees, associate degrees, and we send them to apprenticeship students, which is a different kind of program. Some of our survey results, we want to keep them separate. Others, we want to put them together. Those are two different tables. The apprentice survey is completely different than this one. But we still want to take the answers from those two queries and put them together and create one result set. The only way to do that is with a union command. What the union command does is it gives me the union of the two answers, removing the duplicates. Now, something I want to mention, most set operations can be done, sorry, I'm scrolling too fast here, can be done using a join. However, there was no way for me to join my two answer sets from two different tables into one query. It wasn't possible without a union. There are some types of queries that can only be done with a union. Anything you can do with an intersect and a minus, you can also do with a join. Absolutely. No exceptions. Okay, so let's talk about the rules for using the union operator. Let's talk about that one first. because there are often examples where we can't duplicate the results without using with a join. So my examples here I think are kind of lame. Display the destination, the trip date, and expenses for all trips over $900 combined with all trips to New York. Okay. Really two queries here. Could I do that with a join? Yes. I'm going to show you how to do it with a union first, and then I'll give you the join solution. I want to display the destination, the trip date, and the expenses from TBL trips where the expenses are greater than $900. Want those sorted by date. Change my, at least for right now, I'm going to change my mind and say order that by expenses just so I can see that they're in the right order. I say greater, yep. No 800s, no 700s, just the $900 expenses. Then I can say, give me a list of all the destinations, trips, and expenses for New York. It's a different answer, right? To do a union, you simply take those two queries and combine them. Notice I took the semicolon out because this is now becoming one query, and just stick the word union in between, and this is definitely the way I lay this out. One query above, another query below. I test the individual queries first to see if I'm getting the right answers. All of these are trips to New York. And that's a terrible example. Because none of, I'm going to change it to Chicago. I'll tell you why in a second. Still a terrible example. Okay, that's better. The reason I picked this one is because Miami has a couple of trips that are over 900. The other two examples, New York and Chicago, they are all below. Okay. So now, the union, what does it do? I've got two queries. Think of the circles up on the board. This is query A, this is query B. They overlap, right? There are two trips to Miami that are also in the list from A that are greater than 900. They overlap. When I union them together, I get the two answers combined with the duplicates hopefully removed. Incorrect use of union. I don't think you can do an order by in both. But somewhere there were Miamis that were over $900, but notice how often it shows up. Once. And then there was another one that was over $900. There it is. It shows up once. So the duplicates are removed. That's the key part of a union here that can save you a little bit of grief. So the duplicates are automatically removed. So when you think of those overlapping circles, that little wedge in the middle, those records that are in both results do not get included twice. Unions that helped me get my head around queries that were just too complex to do with a join. Could be done with a join, but I just could not get it done. When I split it into a union, it worked. There's really only one rule now for these set operations that you need to remember. The rule is that the two queries that you're using in set operations, here's query A and query B, they must include the exact same field list. You cannot union two queries that don't have the same list of fields. They have to have the same columns in the result set. Have to. If on one of these I say also give me the employee ID, should get an error. It's interesting. It said it returned 61. Oh, there it is. Use select statements having a different number of columns. Can't do that. And if you have different, I can't imagine having different names here but the same number of columns. I don't even know why I would want to do that. It would get really confusing. So my rule and your rule for the homework assignments, when you're doing unions or any set operations, the two queries must have the exact same field list in the same order. So give me the destination, trip, and expenses over 900 and combine that with the destination of the trips to Miami. This one I can do because both of these queries both use table trips. They're coming from the same place. If they were coming from two different tables, I'd be in trouble. I can, however, take this query, convert it into a normal join. I want to select the destination, the trip date, the expenses from TBL trips. What? Where the expenses are greater than 900. What do I put in here? What? And? Let's go back to our circles. When we do and, they have to meet both criteria, right? How many of these have been, how many of these are greater than 900? All of them. How many of these are in Miami? Those. I did a union. A union's an or. Is it in this circle or in that circle? So a union translates when you're converting it into a normal join, translates into an or. And when it worked, I got 61 rows. So now let's see if we get any duplicates here. I don't think so. I don't think we're going to get any duplicates. We should still get our 61 rows. Yep. So in this case, because the two queries, A and B, both refer to the exact same tables, one, I can replace that with a join. And the join is a little simpler, right? Because it's not quite so much redundancy there. But there are circumstances, particularly where this is from one table, this is from the associate degree table survey, and this is from the apprenticeship surveys table. The fields are in two different tables. Joining them, they don't have anything in common. The students here are either associate degree or apprenticeship. There are very few who are both. And I don't want the ones who are both. I want to combine those two answers, and that's from two different tables. I can't link the tables because they don't have anything in common. But I can run queries from two separate tables and then using, as long as I have the same field names. What if the field names are different? But they're basically the same. Are you really happy with mid-state? Okay. Did you get a job within 6 months in your career field? Well, those we ask of both. If the field names are different, then give them aliases to make them the same. That's all. But normally those field names would be the same. Happy 6 months career field. Happy 6 months career field. Take those three from two different tables and combine them. There's no way to do that without a union. Now, Joni said and. What if I modify this query? We already know the answer here. And put an and in here. Now what does that represent? This thing in between this guy. So an and correlates to an intersection. The or corresponds to a union. The and corresponds to an intersection. How many trips are there to Miami that are over $900? There were 2, right? How do we do that with an intersection? Do we need to? No. Anything you can do with an intersection, absolutely, positively, you can do with a join. What am I really saying? Where's my other query here? Here's my union. I'm going to copy that, paste, and instead of doing an and, I want to do an intersect. Uh-oh. MySQL goes, nope, not doing it. The writers of MySQL said anything you can do with an intersect, you can do with a join. Absolutely, positively. There is no intersect command in MySQL. There is, however, an MS SQL. There is an Oracle. I haven't checked in Access. I don't do a whole lot of these intersections and unions in Access. So you can't do this. I can't test it. I can't test it. In your homework assignment, it's extra credit for you to come up with an intersect query that corresponds to this join. It's extra credit because you can't test it. But it's easy. You simply take your union query that you can test and replace the union with an intersect. It's the easiest half point you're ever going to earn, unless you misspell intersect. It's that simple. Well, you have to have a union query, but you will because I make you do the unions first because that's possible. Then I give you extra credit for giving me the corresponding command in an intersect. But remember that intersect is the corresponding to and. Now the final one is a minus. Remember the minus said, give me a list, back to my circles here for the recording, give me the list of all the trips that are over $900. But remove the ones from Miami. We can do that with a join. There. Give me a list of all the trips whose expenses are greater than 900, but not the Miamis. Take the Miamis out. You see that in the circles up there. Sometimes those circles really come in handy. And so before we had, what was it, 61 rows? So now we're taking 2 out, there should be 59. Bummer. 24. Greater than 900. How many? Oh, the greater than 900, there was 61 combined when I unioned them. I'm sorry. Well, we just did the 900. How many are there? $26. So that's good. Now we said take out the ones from Miami, 24. So that's correct. So we can do that with a union. Anything you can do with a minus, you can do with a union. Guess what? MySQL doesn't have a minus. But this, again, is an extra credit, but it's a little trickier. Gotta be careful. Because up here we changed it to not equal Miami, so your first instinct is to come down here and say not equal to Miami. No. This says give me all the list of trips greater than 900, subtract out the ones that are equal to Miami. This one's phrased a little bit differently. Give me the 900s except the ones that are in Miami. This one says give me all the 900s, subtract, minus the Miami, the ones that are equal to Miami. Same answer. Can't run it. So there's this little trick here. This one to do the join, you have to put the not Miami in there because I don't want the Miamis. But when you subtract, you want to subtract the ones that are equal to Miami. We're subtracting the equal to Miami. If you put a not equal to, and I get that a lot, you're pulling out everybody except Miami. And you get 2. You get the intersect if you do it that way. Union definitely comes in handy. I've used it 3 or 4 times. It's not common. I've used it 3 or 4 times. Needs to be in the language. Intersect and minus do not. You can do them using joins. But that's this language, this version of SQL, MySQL. The other versions do have intersects and minuses because they come from set theory, and I guess the set theory people like those concepts. Still think the join's a little easier. So there's the descriptions. What's left? That's it. I got one more thing to talk about. Then we're done. So then we're done. That means we have to do an assignment before we leave, and we also have to plan for lab next week. The last topic is any and all. These are keywords that you can use in a query. Any and all are used with subqueries. So I want to select, let's just stick with these. Destination, trip date, expenses from TBL trips. I want a list of the expenses that are larger than any expense or all expenses. Any expense, let's start with all, then all expenses for trips to Chicago. How do I get all the expenses to Chicago? It's a subquery where the expenses are greater than a subquery. No, not greater than. Greater than? Greater than, yep. Greater than all. So this is going to say select the expenses from trips where the destination is Chicago. So what does this say? Go find me all the expenses for all of them for the trips to Chicago. Then we say, give me the destination, trip date, and expenses where the expenses are greater than all of them, every single trip to Chicago. Remember, Chicago never made it to 900. Notice Chicago is not on the list. It can't be. We said, give me a list of all the trips that are greater than, What does all mean? What's another word for all here? When we say greater than all of them, what does that mean? Greater than the largest. Because if it's greater than all of them, it has to be greater than the largest. So what's the largest trip to Chicago? Well, we can figure that out using a max. As it turns out, anything you can do with an all, you can do with a max. I got 61 rows, probably not. Time to clear this. I got 33 rows. I got 33 rows. It's just a different way of doing it. We're saying, give me a list of where the expenses is bigger than all of them. It's the same thing as saying the largest. If I change the keyword to any, now what I'm saying, give me a list of all the Chicago trips and give me a list of the trips whose expenses are bigger than any of those to Chicago. What's the alternative? If it's bigger than any of them, it's bigger than the smallest one. So the alternative to any is min. It's just an alternate way of doing it. I believe one of the assignments says use any or all. Just to experience it. Why do they provide us two ways to do these things? Probably because somebody at MySQL said, hey, when I worked at Oracle, we had any, and that's what I'm used to, so let's put that in this language. Plus, it kind of reads better, right? Well, I don't know if it reads better or not. But it's an alternate way of saying, give me the expenses that are greater than any of them. Now, you can't use an equal to. It has to be a greater than, can use a less than, can use a greater than or equal to. Can't just use equal to. Oh, can you? Whoa. Look, I got all the trips to Chicago doing it that way. But what I would have also gotten is any trip to anywhere whose expenses were $791.76 because that's on the list from Chicago. It's in there. I've never used that one before. Questions? The questions will come. So we have lab days, so you can be in here trying these things, and when you can't figure them out, you can ask me questions or ask for clarification, or can you remind me where in your notes the any's are. That's why we have lab days. So Tuesday will be a lab day. Am I in the right class? Yes, Tuesday. Tuesday will be a lab day, all day, 2 hours, or an hour and a half, whatever it is. I'll be here for 2 hours. I recommend you use that time to do multi-table queries. You shouldn't have anything else on your plate because your single table queries were due a while ago. So work on the multi-table queries assignment. My advice is work on it over the weekend so when you come in Tuesday, you have questions. But you got other things, other classes, evil programming instructors making you do things. Maybe you don't have time this weekend. That's okay. The assignment is about as long as the single table queries assignment. So how much time do you think you need? How many assignments are left in this class? After this one, maybe two. And this is the kind of planning you got to start getting into because we're getting close to the end of the semester. It's still kind of far away to me. I think we got 5.5 weeks after this week. But it's something we can think about. And again, we can set dates for these and you can always go later, right? Or turn it in early, excuse me. 25 points according to this. There's today. Give me a date. Lab on Tuesday. $16? 16. 17th gives you an extra Friday when we don't have classes, but I'm around. Usually playing Dean, but what?
Part 3, database 17.
Okay. I don't care about that evil twin of mine in your programming class, but that is something you can worry about. The other difference, 17, the 16 to 17 to me, if you haven't figured it out, doesn't make any difference. I have usually this much time during the week to do grading. So whether you turn it in on Thursday or Friday, doesn't matter. I'm probably not going to look at it till at least Friday, maybe Saturday. 17th. And you can still turn it in on the 16th. If you're trying to help your friends by making them do it earlier, you can talk to them outside in the rain and see if they like that idea. But okay, 17th. It's in there. That way you can trash your whole Friday if you want to working on this assignment. All right, that's all for today. See most of you in an hour or half an hour.